These notes are on the ready of 1.3. In the ready, they give you a table, similar to the one that we have here, and they ask you a variety of questions. So, example 1. One of the types that they're going to ask you are for f of n equals 23, what is the value of n? So in this case, they're asking me about f of n, so I'm looking at the f of n row. And I look at the f of n row, and I see right here, this is where f of n equals 23. And they're asking me for the n value. Well, the n row is above, so at f of n equals 23, I look above, and right there we see that n is 4. Second example type that they will ask you in the ready is they will say that f of n equals some value, in this case 33, and they will then say what is the value of f of n minus 3. So in this case, I need to again find the f of n equals 33. So again, I'm looking at the row that has the f of n values, and I find that right here is where I have 33. You'll remember that with the recursive notation, that this here, this negative 3, minus 3, and minus 3, tells me how much forward or backwards to go. So this tells me to go 3 backwards. So I'm sitting here right now, and I'm going to go 3 backwards. 1, 2, 3, which means f of n minus 3 equals, and let's count it again, I start at 33. The f of n minus 3 tells me to go backwards 3, so that's 1, 2, 3, equals 3. Example 3. In this example, they tell us that f of n equals 13, and they say, what is the value of f of n plus 2? So this is very similar to example 2, except that instead of going backwards 3, I'm going to go forwards 2. So I first need to find where on this table f of n equals 13. So I go to f of n, I go to 13. Again, this notation means go forward 2 spaces. So if I'm starting at 13, forward 2 spaces, that's 1, 2. So f of n plus 2 equals, and let's count it again. I start at 13 and I go forward 2 spaces. 1, 2. 33.